Hey guys, today we'll be talking about sorting algorithm in JavaScript, and today I'll be using two examples of sorting, which is two of the most efficient sorting algorithms in JavaScript, which is merge sort and quick sort. Okay, so welcome back to the channel. If you have ever wondered how sorting algorithm works or which one to use, you are in the right place today. I will try to break down merge sorts and quick sorts and try to explain each of them better to you. Okay, so in this video I'll be covering how merge sort and quick sort works, and I'll also be taking you on step-by-step implementation of both algorithms. Then I'll be showing you the best cases, the best use cases, and also performance comparison. Okay, so by the end of this video you understand which sorting out method is best for your coding interviews and real world applications. So let's dive in. Okay, so first I'll be starting with the merge sort, which is a divide and conquer algorithm, meaning it splits the problem into smaller parts, solves them individually, then combines the results. Okay, so we'll be using recursive programming to actually do that. Okay, so we'll see how merge sort works by dividing the arrays in both halves, then recursively sort each half, then manage or merge the sorts halves back together. Okay, so yes, that's what we'll be doing. So let's write the code now. Okay, so first we'll be sorting we'll be implementing this merge sorts. Okay, sorry. So we want to have a function of merge sort. Okay, then we want to have a parameter of array. Okay, so the first thing I'll do is I want to take care of edge cases. Sometimes we might have an array that is empty or has only one element. Okay, so for that condition, I just want to put a conditional statement here and check if array dot length is less or equal to 1. Okay, so with that we are taking care of two uh two edge cases. Okay, so if it's true, then I want to just return the array back to us, because at that stage we don't need to sort anything. Okay, but then if it's false, then first I want to share the array into two, and I want to say const meet, which will be equal to math dot floor, because I want to use a math dot floor for it. Okay, then I want to say array dot length, okay, divide by 2. Okay, so I've just cut the array into two like that. Okay, so next I want to get the left side of that array. Okay, so left will be merge sort, because we are using, don't forget I said we are using recursive method, right? So we are using the merge sort again, right? And we want to say array dot slice. Okay, array dot slice, want to slice it by 0, then by the mid, because slice takes in mostly two parameters. Okay, then I want to get the right of the array, the right side, though we have just divided to 2, so I want to get the left side, and I also want to get the right side of the array. Okay, so I'm still using the merge sort. Okay, then I just want to take the mid now. Okay, so I want to slice by the mid. So that's all. Next thing I want to do is I just want to return a helper function, okay, which is merge. Call it merge. It is not defined yet, but I'll just call it merge. Then inside of it I'll return the left and the right. Cool. Okay, so next thing is I want to um, implement the second function, which is the helper function. Okay, and I want to call it merge. Then the parameters of left, which we added as a return value in merge sort, left. I want to also get it right, like that. Okay, so first thing I want to do is I want to set results to an empty array, okay, because I'll be pushing things into that result value later. Okay, so next is I want to define my I, I'll call it 0. Then I want to define j, because I'll be using a while loop to loop through the result, or to look through uh, the left and the right side of the array. Okay, so I want to say while so while the I is less, so it should be less because that's the condition we need to set, is less than left dot length. Okay, if it's less than left dot length, and then and if j is also less than right dot length. Okay, then if those conditions are true, if both of them are true, it will run this code block. Okay, so inside of this code block, I want to also set a conditional statement. So I want to check if left is less than, if left I is less than the right. Okay, if it's less than that, then I want to just push, sorry, I want to push the value of the left into the result. Okay, so let me just put it that way. So what I'll just be doing is left, then I plus plus. Okay, then I want to come out and just say else. That's if it's false, then I just want to push the right. Okay, result dot push. Okay, right, that's j plus plus. Okay, so that's it. And then come outside of the while loop. I just want to return in an array. I want to return the results. So I'm spreading the results inside of the array. And then I want to spread the results. Sorry, this is supposed to be results. It's supposed to be return. Okay, I want to return the results. Okay, so that's why we're having that error, right? So I just want to I also want to spread the left, but this time I want to slice it. Sorry, I want to slice it, not splice. Okay, by I. Okay, then I want to also spread the right, then slice it by j. All right, so that should be it. So let's try and test our results or test our implementation. Okay, so I just want to say const so I can also say const array, then I just want to give it a number of 1 to 8, but then it will be scattered, right? So what we want to do here is for it to sort the numbers for us and give us in the right order. Okay, so I can say 8, 4, 5, then 1, then 3. We don't have 3 yet. 2. Okay, what's the number we don't have yet? 7. So we have 1, 2, 3, 4, 5. We don't have 6 yet. Alright, so we have a number from 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so next thing is I just want to console the log so that you don't waste time on this. And just console the log merge. So that should be merge sorts, which is our main function. Okay, then I want to just put the array inside of it. Okay, so I'm getting error saying slice array dot slice is not. Oh, sorry. So I mistakenly add media without adding the array slice. Okay, so we just say array dot slice, then I just want to add a mid. Okay, so with that we should have our sorted results. Okay, so now you can see that even though it is not in order here, we now have it in order from the results that we are getting. So I can just copy this, just put it out here so that you can see it, then we can comment it out. Okay, so that's it. With this implementation, uh, the array which was scattered here has been rearranged for us and sorted in the right order. Okay, so what I'll be doing is I'll be doing this in using the quick, okay, the quick sort, right? So now quick sort also follows the divide and conquer principle, but in a different way. Okay, it follows it in a very different way. Okay, so what quick sort does is to pick a pivot element. Okay, so that's what it does. It will pick a pivot element, which is the last element of an array. Okay, then it partition the array. Okay, so any element that is smaller will go that is smaller than the pivot will go to the left, while anyone that's greater than the pivot goes to the right. So that's just it. Then it recursively sort both sides, then bring them together to give us our final result. Okay, so that's what quicksort does. So don't let us waste much time. Let's go into it. So to sort the quicksort, and say function, then let's just use quick sort like that. Then we are adding the array, then the curly brackets. Okay, so as we did in the first one, I just want to check for empty array and if we have just one number in an array. Okay, so I just want to give an if statement to check. So if the array dot length is less or equal to 1, so it should just return back the array to us. We don't need to stress ourselves for nothing. Okay, but so if that condition is not true, okay, so I want to say left, I want to get the left side. Okay, oh sorry, I need to just first get the pivot number. Okay, so the pivot number here will equal to the array. Then I want to get the array dot length. Then I want to minus 1. Okay, so with that we'll get the last element of that array. Okay, yeah, like that. Okay, so next is I want to get the left, say left. Okay, so now select left. This time it will be equal to empty array, and then I can select right and just set it to also to an empty array. Okay, so here I'll be using for loop to loop through this. So I'll say for loop for, so let I should be equal to 0. Okay, then I is less than array dot length. Then I want to increment I. Okay, all right, so then the next thing I want to do is I want to add a conditional statement. So I want to check if the array, if the array I is less than the pivot number that we have. Okay, so if that is true, I just want to push the value of the array that I want to push that number, right? So I can just say left dot push. Then I want to push the array number, that particular number, I want to push it into left. So when the number is less than the pivot. Okay, but if that is not true, that is the pivot is not less than the array, okay, that is the array is not less than the pivot, sorry, then I just want to push it to the right. Okay, if you listen to the way I explained it, you understand why we are doing this. Okay, so we take the pivots, anyone that is lesser than that pivot goes to the left, and anyone that is greater than that pivot we go to the right. Okay, so we are solving it in two ways. Okay, then we will also we now bring both of them together recursively. Okay, you will be seeing that. All right, so I'll just push the array number, okay, into it. That's it. So we'll come out of the loop. Then I just want to return. I want to return in an array. I want to spread the quick sort. Okay, I want to spread the quick sort and put the left array into it. Then I want to also add the pivot, which is the middle number, which is the last number, sorry. Then the next thing is I want to spread the right, that should be dot. Okay, I want to spread the right, sorry, quick sort, right. Okay, so with that, we should have our results for sorting algorithm with quick sort. Okay, so what I'll just do is similar to what we have done before, but this time, okay, so I can just copy this to save time. So I can copy this and just bring it down here. So what I'll do here is just add one, then I'll also add one to this, and then I can just change the mesh sort to quick sort. Okay, so we are having an error. Okay, so yeah, code, that's how code is. So you have to be very careful while working with algorithms like this. Okay, so we have the quick sort, we are spreading it out in left, we have the pivot, we are spreading out the quick sort of right. Okay. Oh, sorry. So yeah, the mistake I made here is I forgot to skip the pivot while looping through the array. Okay, so to do that, we'll have to add a -1 here, and then we should have our answer, because I don't want to add the pivot number to the number I'll be looping through, so I need to remove it. I need to make sure that that is skipped when I'm looping through this array. Okay, so that's it. That's how to do sorting with both merge sort and quick sort. So okay, so let's talk about the comparison between merge sort and quick sort. Okay, so although both of them uses divide and merge approach to implement sorting algorithms, quick sort is more of a divide and partition approach. Okay, so yeah, so the difference between comparison between them, as I'm saying, so on time complexity, merge sort will always yield a time complexity of O of n log n, okay, in any case, right? And for space complexity, it will always yield O of n, right? That's it. But for quick sorts will also yield a time complexity of O of n, but the bad side of quick sort is it can also lead to O of n square, because as the array becomes large, so the time it takes for the implementation to run also becomes larger. Okay, so it has this tendency of leading to O of n square in its worst case. Okay, so yeah, so mesh sort is best when you need stability and can afford extra space. Okay, but quick sort is faster in practice, but like I said, it can degrade to the case of O of n square, like if the another one is if the pivot is poorly chosen. Okay, and then as the array also becomes large, so the time it takes the implementation to run also becomes larger. So if we want to put this in a real world application, right, so merge sort is used in sorting things like linked lists, since linked lists don't have random access. Okay, so external sorting, you can also use it for external sorting where data is too large to fit in memory. Okay, but quick sort is used in programming languages like Python's time sort uses a mix of, yeah, so like Python time sort uses a mix of quick and merge sort. Okay, so quick sort is also good for sorting database efficiently. Okay, so yeah, it's good for sorting database efficiently. All right, so there you have it. We covered merge sort and quick sort, explain how they work, and compare their performances. Okay, so yeah, so which one will you prefer in your next sorting algorithm? So you can comment below. If you found this helpful, don't forget to like this video, subscribe for more tutorials, drop a comment on which topic you would like next. Thanks for watching, and I'll see you in the next video.